Hi folks, good afternoon and thank you for joining me for my very first episode on my series of talks on CosmosDB. Cosmos database, as you may be aware, is an Azure PaaS solution offered by Microsoft. uh, CosmosDB is basically a NoSQL database. It is a tier 0 PaaS solution offered by Azure, and it has multiple different flavors. You can use Cosmos DB with different client flavors in a sense. You can use it with Mongo, with the native Cosmos SQL API, with Cassandra, and also has a client for Gremlin, the Gremlin API. Now, each of these APIs that you choose, it's basically a static lock-in. So once you choose to, for example, go with the Cosmos SQL API, you cannot switch to another client for that database instance. So today what I plan to do is I plan to basically go over how the Cosmos database handles write operations. And this is very fundamental to all of the different consistency levels that will be building up on top of this basic foundation. Okay, so as I was saying, Cosmos DB is available in multiple regions. It's available in all regions that Azure is deployed in. We'll take South Central US as an example. Now, in South Central US, let's say that that's my region, and I have an app here, and this app is doing a write. Okay, so in this case, let's assume it is just doing an add operation. So it's doing add, it's key 1, v1. Now, in this write operation, essentially when it comes to Cosmos, the Cosmos database internally maintains 4 separate replicas per region. Okay, so if this was my Cosmos database, within this I would have 4 separate regions. 4 separate replicas. So whenever a write happens, this write is now propagated to all of the replicas. Okay, and there has to be local quorum for the write operation to be successful, which means 3 out of 4 replicas have to acknowledge that write so that the application knows that the database has successfully acknowledged that write. Okay. Now, typically each of these replicas, they are in different availability zones or fault domains. Different cloud providers use these different terminologies. A fault domain or an availability zone is basically an isolated region within this Azure region. It's an isolated boundary which has its own independent network and power. So as a result of which, it's basically adding in more checks and balances against outages. So if one of these replicas were to go down, think of these just like 4 separate computes in 4 different availability zones within this region. So if one of these computes were to go down, the others can still take over without your service being disrupted. So it is highly available and offers a lot of fault tolerance there. So this fundamental approach of having a local quorum is fundamental to the overall design of how Cosmos provides these write capabilities. Now, we'll now go and look at different kind of consistency levels in the next episode. Thank you. Now that we've gone over the write operation and write behavior of Cosmos, now we'll look at the different consistency models that the Cosmos database offers. Okay, so it's basically a broad spectrum. starts with strong consistency on one side of the spectrum and ends with eventual consistency on the other end of the spectrum. Okay. During this, there are other configuration options available to you in this band. Number two in this case is something called bounded staleness. After that is session consistency, and session is the default. Whenever you provision an account with CosmosDB, you will get it with session consistency as the default. And then there is consistency prefix. So what do all these different consistency levels really mean? We'll look at an example, and in this example, we are basically going to look at two Azure regions and then see how this behavior works. Okay, so let's say we have our first Azure region. This is South Central US. I have an app deployed here, and it writes to Cosmos database here, and we'll have another region, in this case let's say West US, and this also has a Cosmos database provisioned here. And of course, like I've talked in the previous section, there are 4 replicas within each Cosmos account, so we're not going to go into the details there in this discussion. We will look at it furthermore as we keep peeling this onion. So let's say that we are configured with, we're looking at the first one, which is strong consistency. The app does a write operation. It adds a value key1 v1. Now, if your account, so before I do that, your Cosmos consistency levels are provisioned at the account level. So all your databases and your containers, collections, and so on and so forth, under that account will run with the same consistency level. You can't choose different consistency levels within different containers within a same account. Okay. Now, there are other options that you can handle at the client level. We'll talk about it later. For the purpose of this discussion, we are only going to focus on the server-side account level consistency setup. So when we take strong consistency level, it basically means it is fully linearizable, which means you are guaranteed to be able to read your last write. Okay, so when you write, when your application comes and writes a value of key1 v1, if your application is deployed in West US and you issue a get call, get the value of key1, you are guaranteed to get the value v1 back. Now, how does that happen? Internally, what happens is the moment you do a write here, this get call incidentally was issued to its own local database, okay, within West US. So it did not have to cross the region and make a cross-region call for the get operation. Okay, so the way this works is when you do an add operation, there is replication that is happening from one database to the other database within the same account. This is provisioned for multi-region, and this replication is synchronous. This basically means that the key1 v1 write that that this was initiated by this application, it's going to have to wait until the time the whole round trip is completed and the write was sent over, propagated over to the remote region. In this case, let's say that this was primary and this was my standby or my secondary region. So it's got to wait. Although you did a local write in this database, you have to wait for the round trip to succeed to the remote region, because this is what is going to guarantee you that full linearizability. Okay, because it's got to propagate it out. So that is strong consistency. Guaranteed, you will be able to read your latest write at the cost of slower write operations. Okay. Now let's look at the second one, bounded staleness. Now, in the case of bounded staleness and all other consistency options, this synchronous replication that we talked about in the case of strong, it becomes async. Okay, so that's key here, because strong consistency is the only consistency level where this replication is happening synchronously. In all other consistency levels, it switches to async replication. So now with bounded staleness, what happens is your whatever writes you're doing, you're able to lag behind, or you can potentially lag behind by a configured number of writes or time. So I know it will be a bit confusing. Let's look at it in a bit more detail. So when you choose bounded staleness, you can be either lagging behind by a prefix number of operations, write operations, or based on time. Okay. Now both of these can be configured. You can say I accept to lag behind, for my reads to lag behind by a maximum of 100 write operations, or I can lag behind by 5 seconds. What this basically means is, if I am doing a write now and my application issues a get call, it says it issues a get key 1, I can very well get the value of v1 back. But because my staleness is set to up to either 5 seconds or up to 100 writes, if I issue this get call from my remote region, I may get a value which is within this range. Okay, so that is the tolerance level, in a sense, that I am configuring, that my app can accept stale data up to this window. Now, what happens when this window is reached? Let us say my application is lagging behind, my replication is lagging behind. Then the application will start getting throttled. The Cosmos database will take care of that, and it will start implementing some kind of throttling to slow down to basically ensure that the replication catches up. Okay, so now let's take a look at session consistency. As I said earlier, session consistency is the default consistency level that comes out of the box when you provision a Cosmos account. Session consistency is very unique because your writer is guaranteed to be able to read the latest write as long as you read with a session token. That's interesting, right? So what happens is, anytime you do a write operation, in this case again key 1 v1, your client in response, Cosmos, will basically when it responds back, it will give a session token. Now this session token is key. Now when the same thread tries to issue, the client thread tries to issue a read request, it has to use that same session token. When it does that, Cosmos immediately recognizes that session token and is able to retrieve and return the latest value. Okay. So again, we'll go into more details as the talks continue. But in the meantime, we'll just continue today to the next consistency level, which is consistency prefix. Now, in the case of consistency prefix, again, it is not as, it has a looser, a more loose guarantee compared to session. And it basically says that whenever you read, you will never read out of order messages or out of order data. So let's look at that. Let's say at time t0, I wrote a value key1 v0. Time t1, I wrote a value, I updated the same document and I set up a value of key1 v1. Time t2, it was key1 v2, and so on and so forth. So if I ever issue a get call with consistency prefix, I am going to get values in this order. It could be v0, v1, v1, v2. It could be very well be v0, v1, v2. But you'll never get an order or messages that are v2, v0. This would not be returned. So if it is out of order, it will not return out of order messages. The data will always be returned in order. Okay, there may be gaps, but it will be returned in order. Okay. Now, the last one is eventual consistency, and in eventual consistency, there is no ordering guarantee. So when you issue a get call, you very well may get values v2, v0, v1. There's no guarantee around that. Okay. So at a high level, this is what is offered by Cosmos out of the box as different kind of configuration options for consistency levels. And that's it. Thank you so much.